everyone, this is V. Ritika and A. Jennifer Bison from PG and Research Department of Mathematics. Architecture, the art of designing and constructing buildings. The relation between architecture and maths. Geometry, algebra, trigonometry all plays a crucial role in architectural designs. Architects use geometry to study and divide space as well as draft detailed building plans. Algebra is used in architecture to calculate how large to make certains on the basis of size of building designs. Trigonometry functions are used to calculate height of structures, light angles, exact intersection angles. Next, let's see about how math used in dam construction. The concept of mathematics is used to calculate all the measurements. The speed of water will be calculated while flowing, which will also need the mathematical concept. As the example, let's see about math in Kallanai Dam, that is the Grand Anicut. About 2000 years ago, the great Chola, who ruled most areas of southern India, named Karikala Cholan, built the dam Kallanai. During his period, the country was prosperous and rich. The main reason was the river Kaveri. It flows from Kudagumalai to Tanjai, but the river was not much useful as they were mixed in ocean. So King Karikalan planned to build a dam to make the river water useful. Nowadays, there are many technologies and machines used to build any construction. But during their period, there was no such machineries. Also, the river flowed at the very fast rate as 2 lakh cubic feet per second. Under such circumstance, Karikalan was confused. He didn't know how to build the dam. With this thought, Karikalan took a walk on the seashore of Kaveri Pumpatinam, which is known as a Bumbuhar. He noticed that his feet was buried inside the soil. From he got an idea, that is soil erosion theory. Soil erosion is a denudation or wearing away of the upper layer of soil. It is a form of soil degradation by detachment of soil particles by raindrop impact, splash or flowing water. While the seashore touched his feet, the soil particles around his feet were detached by the flow of water. The great Cholan, Karikalan, decided to use this method to build foundation to his dam. Since the Kaveri river flowing at very high speed, it is impossible to build the foundation by digging the soil. So he decided to use this soil erosion theory. If the dam needed to be stronger, its foundation should be from 50,000 cm to 30,000 cm. As he decided to build the foundation by joining rocks, the people of that period didn't know the rock's weight. So Karikalan came up with the idea, that is, he took 10 gram stone and put in it the side of the river bank. It reached 2 cm. Then he took 30 gram stone and repeated the process. It reached 6 cm. Before that, we must know about function. A function is defined as the relation between a set of inputs having one output each. The function is denoted as f of x to y. First, I have given input as 10 and I get output as 2. Then, I have given input as 30 and get output as 6. Here we have taken the stone mass as x, that is input, whereas the depth as y, that is output. Here we can able to see that the mass is 5 times greater than the depth, that is 5y equal to x, which implies us y equal to x by 5. Y equal to 30,000 cm. We need to find x. X equal to 5y. X equal to 5 into 30,000. X equal to 1,50,000 gram. That is, we needed 1,50,000 gram stones to reach 30,000 centimeter in depth.
Let's describe function in diagrammatic. We taken two circles as input and output. Input is known as domain, whereas output is known as codomain. During Karikalan's period, there is no advanced mathematics. He built the Kallanai Dam with the basic mathematics is known as Tamil Enkanidam. Later, it was named as a function by European in the 18th century. Karikalan started to build the dam by using his all forces. He faced many problems that the speed of river is not constant in all area. That is, the center molecule of water is very fastest, while the water at the side of river bank is slower. It causes because of friction. The water molecule near the side of river bank touches the riverside soil with high speed, which result in high friction and low speed, whereas the center of the river have high speed and low friction. That is, when Karikalan took 10 gram stone and put in the side of river bank, it reaches 2 centimeter. Then he again takes 10 gram stone and put in between the side of river bank and center of the river. It reaches 5 centimeter. By seeing that, Karikalan discussed about with his minister. One minister suggested that soil erosion is based on both the mass of the object and the speed of water. Now, Karikalan decided to collect set of values from river. Now let us see about the graphical representation of set of values that was taken by Karikalan. We took mass in x-axis and depth in y-axis. The function of this graph is y equal to x by 5. The mathematical representation of this function is f such that x tends to y. X belongs to mass of stone. Now let's plot the values in graph. First, 10 gram stone went 2 centimeter in depth, so mark 10, 2. Then 30 gram stone went 6 centimeter in depth, so mark it as 30, 6. Also 1,50,000 gram stone will reach 30,000 centimeter in depth, so mark it as 1,50,000, 30,000. By connecting these points, we get a straight line. These are the set of values of the side of river bank. Now let's mark the point 10, 5 as the 10 gram stone reaches 5 centimeter in depth in between the side of river bank and the center of the river bank. Here we can able to see that one input has two output. This is not a function. In function, every input should have exactly one output. Karikalan doesn't able to form a correct function to build the dam because his input data gives many output. So he again discussed with his minister to think of a way. By the ideas given by the minister, Karikalan took 10 gram stone and put in a side of river bank between the center and the side of river bank and at the center. He collected all the depth reached. With the collected data, the minister tried to write a function. The 10 gram stone reaches 2 centimeter inside of the river bank, 5 centimeter in between the center and the side of the river bank, and 20 centimeter in center of the river. We know that in function, one input should not have more than one output, but here we get 3 output for a single input. Here we changing the function as f such that y tends to x. That is, here we have taken y as an input and x as an output. This is known as inverse function. Inverse function is a function that undoes the action of another function. It is denoted by f inverse. Let's see the mathematical representation. Here we get one output for 3 input, which is possible in function. This type of function is known as many-to-one function. Here x is equal to 5y. This is the function needed to build the dam. As the river is vast, they can't able to build the dam in all areas of river. So they decided to put the stone from side of the river bank to center of the bank. So they separated this many-to-one function into one-to-one function as shown. Now let's see about the equation of this function. Inside of the river bank, output is 5 times greater than input. So 5y equal to x changes to x is equal to 5y. In between the side and the center, the output is 2 times greater than input. So x is equal to 2y. in the center of the river, input is 2 times greater than output. So y is equal to 2x changes to x is equal to y by 2. Here we know that y equal to 30,000 centimeter. For land site, we need x is equal to 5 into 30,000, that is 1,50,000 gram stone. As for inside of a river, we need x is equal to 2 into 30,000, that is 60,000 gram stone. As for center, we need x is equal to 30,000 by 2, which is 50,000 gram stone. These were collected by the ministers of Karikalan. Karikalan built the dam using this function. Here we have.
In this video, we have seen about function and type of functions. Also, how a function is turned into an inverse function. These are only a small concept of max, but it was used by Karikalan to build a tremendous dam. So we should not avoid max. Mathematics is in its own way the poetry of logical ideas.
Thanks for watching. Don't forget to subscribe, like, comment and share.